Hello, this is the 2014 AMC 10A number 13. Equilateral triangle ABC has side length 1. So I'm just going to put that in. And squares, or let me write it the fancy one so that things don't get confusing later on. And squares AVDE, BCHI, and CAFG lie outside the triangle, so they're outside the triangle. Now I need to know what the area is of the hexagon DEFGHI. So the first thing I'm going to do is I'm going to find the area of this equilateral triangle. So since it's an equilateral triangle, all of these have 60-degree angles. And we know that the area of a triangle is 1/2 base times height. I wrote that really weirdly. 1/2 base times height. So 1 is going to be this base, and I need to find this height right over here. So the way I'm going to do that is I'm going to say, since I know that this is 60 degrees, this right over here is 30 degrees, and this right here is 1/2, and this right here is 1. So if I redraw this triangle, I'm going to have this be 60, this be 30, and since this whole length right over here is 1, that means that this half of it is going to be half of 1, which is 1/2. And so what I want to do is find this length right over here. To do that, I'm just going to do Pythagorean's theorem. 1 squared, which is equal to 1, would be equal to 1/2 squared, which is 1/4, plus x squared. That means that x squared is equal to 3/4, and that x is the square root of 3/2. And I'll write that in over here. So that means that when I want to find out the area of this equilateral triangle, 1/2 base height, it's going to be 1/2 times base height, which would be 1 times square root of 3/2, which is equal to the square root of 3/4. So I'm going to write down that I know that the area of this triangle is the square root of 3/4. Next, I'm going to, that was supposed to be a square. I'm going to try and find the area of the 3 squares. So since they're squares, that means that all the different sides are equal. So when this side is equal to 1, that means that this is also 1, this is also 1, and this is also 1. So the area of it is just going to be 1 times 1, which is of course equal to 1. But since there are 3 of them, it's times by 3. So the area of the squares is going to be equal to 3. Next, I just need to find the area of these triangles. So I'm confident that I can find angle GCH, which is right over here, GCH. Because that, since this right over here is 360 degrees, it's just going to be 360 minus 60 plus, and then these two right angles, which is going to be 90 plus 90. So this right here, 180, add the 60 to it, you get 240. So come down over here, it's equal to 360 minus 240, which is equal to 120 degrees. So this right here, 120 degrees. And these also have to be 60 degrees, because everything else is so symmetric. These are also going to be symmetric. So it's going to, since the lengths correspond to the angles and the lengths are the same, that means that the angles are also going to be the same. So since this length is 1 and this length is also 1, that means that these two angles are also going to be the same. So they're both going to have to add up to 100, oh, not 60, what am I saying? They're both going to have to add up to 180, so it's going to be 120 plus 2 of the same thing is going to equal 180. Means that 2 of whatever those angles are is going to be 60, which means that each of those angles are going to be 30 degrees. I don't know why I said 60, sorry about that. Props if you caught me on that though. Anyways, these are going to be 30 degrees. And you might notice that it looks very similar to this equilateral triangle that we had up above, and that's because it is. If we split this up right over here in the middle so that we have a right angle over here, we have this length 1, and then I'm confident that we can find the area of it. Okay, so this, of course, since this is, the whole thing is 120, this is going to be 60, which means that since this is 60 and we have 90, that gives us 150, and 180 minus 150 is 30. So this angle right here is going to be 30. We have another 30, 60, 90 triangle. We found the area of one over here. We can find the area of one over here. So I'm just going to redraw it. I'm going to redraw it like the proper way. Normally you see it like this, where you have 60 right over here and 30 right over here. Now this time, we know that this hypotenuse is 1. And you might be thinking, well, we know 2 angles in one side. How are we going to find the rest of these angles? Again, this whole thing is going to be the base. But if we find just this, we'll know half of the length of the base. And we could just multiply by 2. And this over here, these dotted lines, that's going to be the height. So it's going to be 1/2 base times height times 3. So I'm going to do this cool little trick. If I draw a right triangle right over here, another 30, 60, 90 triangle with the same lengths and everything, that means that this also has length 1. And look, now we have lengths, angle 60, and 30 plus 30, which is also 60. That means that this is an equilateral triangle, so they all have the same side. This whole thing is length 1, meaning that this right over here, this top half, is length half. Now we know that this length is 1, this length is 1/2, which means that this right over here, between 60 and the right angle, that length is 1/2. Now we just need to find the length between the 30 and the right angle. So I'm going to say, use the Pythagorean theorem, 1 squared is equal to 1/2 plus x, 1/2 squared plus x squared. That means that x squared is equal to 3 over 4. And that brings us to x being square root of 3 over 2. So this length right over here, square root of 3 over 2. So now it's going to be 1/2. Yeah, I'm going to write out what we're going to do again. We're going to do 1/2 base height times 3, because there are 3 of them. So 1/2, the base is going to be square root of 3 over 2 times 2, which is the square root of 3, times the height. The height is 1/2, times 3. So we are going to get those two become 1 over 4. Those two become 3 square root 3. So now we have the area of the isosceles triangles, the equilateral triangle, and the squares, which means that when we just add them up, we'll find the area of this hexagon. So it's going to be the 3 square root 3 over 4 plus the area of the triangles, which is square root 3 over 4. Sorry about that, there's some thunder and lightning going on outside right now. Plus, and then the area of the squares, which is 3. This is going to come out, those two are like terms, so it's going to be 4 square root 3 over 4 plus 3. Now notice how these two can cancel out. So our final answer to what the area of that hexagon is square root of 3 plus 3. It's a bit more proper to write the 3 first, but it doesn't really matter. Anyways, thank you very much for watching, and goodbye.